Hi there, my name is Kit, and today we're going to talk about attempting to build real-world apps with SwiftUI and some of the pains you're going to find yourself experiencing. For background, I've been working on this flashcard app called Omen for a couple of years. It's a little side project, and I rewrote it in SwiftUI the second it came out because it seemed very exciting, and I was bogged down in UI kits at the time. It was really painful to make the sort of custom animations I wanted for this app, and I rewrote it in SwiftUI, and those custom animations were really easy to do. For instance, the study screen where cards fly around representing your progress through the study section, that was really quite simple. Even though this is a very visually complex screen, it was an absolute pleasure to write in SwiftUI, and it's not that much code, certainly vastly less code than it was in UIKit. This is where SwiftUI excels, and did at the beginning and still does today. It's even better today at building completely bespoke views like this. Where you're probably going to run into some problems is where SwiftUI interacts with the older UIKit frameworks and wraps them in some ways, or when they expose higher level components and they're not just completely being built from the fundamentals. For instance, the navigation view, it's a little buggy sometimes. This list view, a little weird. In iOS 13, I was able to get rid of these unsightly horizontal bars that separate the cards, and then when I installed iOS 14, they returned somehow, and it is not so easy to get rid of them again. The same hacks that worked in some earlier version may no longer work. So if you fight what the framework wants of you, you're going to have problems. But there are some ways out, and you have to ask yourself when working with SwiftUI, at least at this point, is it worth customizing it? Or can I accept what's given to me? And if you are going to customize something, accept what that means in its fullness. And don't just try to hack your way through it, because that's going to break version to version, and you're going to waste all that time. In this case, clearly, I just accepted the trade-offs, and I'm fine with the way this looks for now. It'll do until I feel like prioritizing this. What I was not so fine with was the built-in editable text fields, because in this new card view over here, I wanted to be able to do a couple of things. First of all, it's autofocused when you open this new card screen, which is not something that you can get using the built-in SwiftUI text fields, which is really unfortunate. As you can also see, we have multiline support, which is also something that's not out of the box at all. Likewise, we can customize the return key here. It says next, and jump to the back. Jumping to the back also, programmatic focus, not something possible with SwiftUI. And these two things I really wanted so that you can quickly just go in, what's the capital of France, and then just get it in there as quickly as possible. That's kind of the design choice I had for this app, and I could not get that at all with the built-in components. So I wrapped a UIKit view and built a nice SwiftUI wrapper around that. And that's the tactic you're going to have to take when you want more functionality than the framework just gives you out of the box. You can hope for that to come. At the beginning, I thought that, TextField clearly couldn't stay so underpowered. Not being able to focus seemed like a ridiculous oversight. Surely that was going to come in beta 2 or 3. But here we are 2 years later, and there's still no focus control. But we're going to take a look at, in the code, how to actually do something like this. And hopefully, I'll be able to open source it, because I haven't seen anything that is exactly what I wanted to have, which is programmatic focus in a nice, Swifty way, as well as the ability to have multi-line support and a few other things. But those were the two really basic ones, because it's really painful. If you use some apps that people have been making with SwiftUI that don't have autofocus, it's really annoying to come to a screen and then have to tap here, type something in, and then tap in the next one. I know it's a small thing in the grand scheme of things, but if you're a weird perfectionist, it really just doesn't fly at all. So let's take a look at how to actually code this, and hopefully it's interesting. We have here a simplified version of the screen we were just looking at, except this is built using the built-in SwiftUI components. So we have text fields and some toggles here. Basically, there's a front and a back, and when we tap in, it shows which one is currently selected via the toggles below. However, this is only a one-way binding, so if we were to activate the toggles, nothing happens with regards to the focus. That's because these are controlled via callbacks. TextField gives us an on-editing change parameter, which allows us to pass in a callback that accepts a Boolean argument, which will represent the current focus of that text field. But because it is not a binding, we cannot change it from the outside. And that's the whole goal here. And the other issue, of course, after that seamless transition, is the fact that it does not ever stop saying mac and cheese. I don't know why this has been happening. But the real problem is that this mac and cheese loop is continuing out horizontally instead of continuing to grow vertically. So we want both programmatic focus, which we lack, as well as multi-line mac and cheeses instead of just a single. It's just not, that doesn't look good for a real, makes sense for some text fields, but not for every single one. So let's take a look at how to actually make this work. So the first thing that we're going to need is a view. So I'm going to make one called TextField. It's going to have a body, which is a view. I'm just going to make it an empty text view for now. And then we're going to add the parameters that we'll eventually need. So we want a binding for text, and we also want a binding for whether or not it's focused, which will be a Boolean. So instead of having a callback, we want a binding, so we can have bidirectional control. We're going to ignore placeholder for now. And in order to actually implement the body, we don't just want to use TextField again. We need to dig down a level deeper, and we're going to have to use something called UI View Representable, which allows us to use UIKit components. So we're going to make an TextField rep and make this conform to UI View Representable. If you just build and let the error tell you what to do, first it says it needs a type alias. This is going to be the type of view we're wrapping, which is going to be a UI text view. And if you build it again and have it fill out the protocol stubs, you can delete the type alias because it can infer this from the return values. And now we have a UI view representable. In order to make this compile, we of course need to return a UI text view. So we can make one here, and now we can use this TextField rep. Okay, lovely. The problem is we need to use these things in here. We need to pass them down a layer. It's just these endless piles of abstraction. It can get a little overwhelming when you first try it, but it does get easier over time. And now we need to pass these along as well. So we're going to pass a binding to text and the binding to is focused. In order to actually use this text, I'm going to assign this to a variable, and then I'm going to override the initial text with what we get. So this at least looks right when we render this. And we can actually get the focus to work. The thing that TextField does not allow us to do, we can get that to work really quickly off the bat. Update UI view is going to get called every time either text or isFocused changes. So using that knowledge, we can check to see if isFocused is now true in that we want this view to be focused, and the view is currently not the first responder, which is the weird lingo for in UIKit terms for whether or not a view is currently focused, then we want to become the first responder. Otherwise, if we want to not be focused, and also checking so that we don't just do this redundantly all the time, that we currently are the UI first responder, we can then resign first responder. So now let's add this very basic half incomplete view to our example here. So I'm going to make TextField. I'm going to throw in front text, and I'm going to throw in front focused. And let's render this and see what happens. Okay, so firstly, we have this ugly black box here, and that's because when we start to use UI View Representable, we lose a lot of the magic that SwiftUI gives us. And this is part of the trade-off. It's not all nice. You lose a lot of the automatically good-looking UI designs that SwiftUI gives you. But it's a trade-off because you get power. So this is tiny, ugly text. We can fix this later. It's not so important right now. But the cool thing is, if we are in the back, we can now hit the front toggle and toggle the focus. This is now connected, which is really great. So while we might be a weird, ugly, tiny, fonted black box, we at least have programmatic focus. So take that, SwiftUI. So that's cool. One step down. Okay, before we move on though, let's fix the ugliness. It's just too painful to countenance any longer. So what we need to do is change the font. And we can use an overload or a method on UI font called preferred font for body. And this is just, this takes text styles that are similar to the ones which the built-in SwiftUI font accepts. So we can get the font right. Next would be the background color. We can make this clear. So that should look a lot nicer. And there's no more box. We can start typing. And there's some problem with the size and the spacing. That's actually going to get partially fixed when we make this actually growing vertically in a good way. We don't want it to grow like this. This does not quite fit our needs, but it's also a little offset on the left, if you can tell, from the actual front, which is enough to drive me insane. And we can take a look at how to fix that as well. So on to the next step. We have implemented so far something that SwiftUI cannot do, which is control focus from the outside. But the SwiftUI view, as you can see, when we select it, it changed the back focus toggle. However, when we select ours, it does not turn it on. So these are unequal views right now. So we have to give our version the ability to let SwiftUI know when we're focused or not. And this is going to make it slightly more complicated. We are going to need one more layer of abstraction. We're going to need to make something called a coordinator. This is going to be a class which we can use to be a delegate of our UI text view. And a delegate of a UI text view also needs to be an NS object. So let's make it an NS object. And once we have a coordinator, we're also going to need another function, which is going to be a make coordinator function, which we can just start out by building one. And now in here we can use all the nice UI text view callbacks. So we can say text view did begin editing and did end editing. And this is where we're going to be able to change that is focused value. So when this gets called, we're going to tell our binding that we're focused. And when this gets called, we're going to tell our binding that we're not focused. The only problem is in here we have no access to is focused because this is just a class definition. It looks like we do. That's actually a lie. Yeah. Instance member is focused of type omen rep cannot be used on a nested instance. Yes, because we're just defining a class in here. So that's the autocomplete slightly lying to us. So we're actually going to need an instance or a handle on the struct, which we can pass in when we build it. That's the convenience of this make coordinator function. So we can pass ourselves into the coordinator. So I'm just going to make this rep, which will be this. And then we can use the little action here called generate member-wise initializer, which will create this fun thing for us. And now coordinator takes a rep and we can pass ourselves in. And now we have access to a rep, so we could say is focused equals true and rep.isFocused equals false. We're almost there. This is a many-legged race. We have to keep jumping around. It's a little annoying, but you get used to it. But we need to actually change the delegate equal to the coordinator, which exists here inside of context. So you're jumping around at all these different levels. It is quite overwhelming at first, but it is the same pattern every time. You eventually figure out where everything lives and some patterns. I hope that by releasing this video and hopefully some follow-up videos and open sourcing this, that you can sort of get a sense of how these patterns work, at least 80% of the time. So now we have this. Let us take a look if it works. Okay, I'm going to tap into the front text view. And lo and behold, it now changed the toggle. Now if I tap into the back, it changes the toggle off and on. So we've achieved it, except now we can steal focus, which is really cool. But before moving on to implementing our growing height feature, we have neglected a couple of more fundamental features, which is the ability to actually update the text. Oh, I got a mac and cheese loop again. This is awesome. Oh, it's very cool to be a cheese sandwich. I agree. So the problem is we would expect the changes made here to actually change this other text field, the built-in one, where it just shows the placeholder front right now. This is actually very easy to do. We need to take it in two steps. One is we need to add a new delegate function, which is TextView did. Oh, I did it already, secretly behind the scenes, in between these cuts. Well, I'm going to keep this here because of that great mac and cheese spree. I'm not going to edit this again. That's a once-in-a-lifetime event. I would not want to steal from you. This is what we had to write. Another callback, just like the other guys, another delegate function. TextView did change. We update our reps text equal to our TextView's text. And then in the update UI view, we change our UI view's text equal to the text binding. So we've connected it in both directions. So I guess I've secretly done that already for you, but that was really the only change. Let me run this again. And now, the job was to get the kids to a good idea, and the job was to be a good idea to have a good job in FP cities. So now that works. That's pretty easy to accomplish. And as a treat, I would also like to give myself this little snippet of code, which will remove that very slight left padding difference. Notice how the H here is inset in a horrid way with these two lines. If we run it again, everything should be nice and aligned on the left side. Ah, yes, at least left aligned. It's still oddly hovering above the center point, but we're going to fix that when we actually get this connected to a growing height. So let's work on that now. This next step is not necessarily intuitive. One could imagine a lot of different ways that this could work in parallel universes, but in our universe this seems to be the most straightforward and easy way to accomplish this. I think this pattern I'm about to explain just kind of falls out of the way that SwiftUI wraps UIKit and deals with things like constraints. It's slightly mysterious to me, but I found this to be quite straightforward once you accept what we're doing. So what's going to happen is we're going to need to add a state variable for height here at the outermost layer. So this text field here, so far we've really just delegated everything to our Omen text field rep, so why are we even using text field? Well, we're going to use this to also hide some other information, such as this height. This should never escape this text field. No one else should be concerned with the height. This is just an implementation detail for getting this thing to grow correctly. So we're going to store the height here, and then use this to dictate the height of the text field rep. So we're going to say the height is going to be exactly this height. The weird thing is that we're going to be getting this height from the inside. So we're going to ask the UI text view, hey, how tall should you be? Then we're going to store that outside, and then we're going to sort of tell it again how tall it should be. So it's a sort of like weird dance step where we go to the very inside first. We're going to ask the UI text view how tall its text should be, then go all the way to the outside to the wrapping view, and then kind of go in between and tell the view representable how tall it should be. This is weird ping pong motion where you go ding, ding, ding. I don't know. It's kind of odd, but it's how we do it. But now that we have the height here, we need this to be modifiable by the inside, by this text view. So we need to make another binding. This will be height, which will be a CG float. And actually we've got to give this a default value so that the outside doesn't, where we're calling this, doesn't need to pass it in. And now we're going to need to add the binding here. And there we go. So now we need to get the height from this text view. And we need to do this in two places, both when we tell this view to change its text, which might change its height, and also when it itself changes its text. There's this bidirectionality, so we need to handle it at both ends. So first, let's talk about changing it at this level. So we're going to actually ask it for the size that it fits given a certain container. So we're going to give it a container, and it's going to return to us the size that it would like to take up in that other container. How will you adapt? We're asking the water, given this particular container, what shape it will take. So we're going to make a new CG size, passing it in a width and a height, both CG floats. The width is going to be its current width. We don't want to change that at all. So we're going to use its current frame's width. What we do want to change is the height. And in order to do that, we can say CG float dot, where is it? Greatest finite magnitude. A bit of a weird one. And this is going to get us back its actual size. And we can just pluck the height off of that. So I don't need to set this to an intermediate variable, but I will just because. And we can say height equals the size dot height. So given this constraint of a size that is exactly your width, but can go on forever, how tall would you like to be? And that's how we do it. And we can just copy paste this and also throw this down here, except changing this to be reps height. And we don't need UI view. This is a different name here. It's text view. We can abstract this and make an extension or something on UI text view that just gets its text height. But for now, This will be fine. I'll try to clean it up if I open source this thing. Okay, so let's think if we've gotten everything. When we change the text, when we type into the text field, it will calculate a new height and update the rep's height. Likewise, whenever the text changes from the outside, that will happen. It might be nice to wrap all of this in a if UIView.text is not equal to text, because sometimes that is a useful thing to do. That's kind of why I've guarded against needlessly calling these functions. When calling UIKit functions a lot, they're not necessarily idempotent. You can run into some problems, or they take up some performance issue. Weird things might occur. So it's nice to have guards in this update view function, because this will change all the time. And you can also imagine that this might go into some kind of loop. If height is being changed and it's triggering update UI view height, that could be a bad thing. So let's just head that off right off the bat. Okay, I think this will work. Okay, and as obnoxious as it is, I'm also going to copy and paste this one more time, because we also want it to set immediately. Otherwise, because of this new guard here, this might not run the first time, so we'll need to do it here as well. Once again, we need to abstract this somehow. But let's try to get this to work. I'm going to run it. We've focused the field. We are now proceeding to click the autocomplete button. And behold, we now have a programmatic, focus-controlled, growing text view that we've always desired since we were... Oh, and we have another mac and cheese loop. This is a beautiful day. I don't know why this is happening. I seldom eat mac and cheese, but that's great. Congratulations, viewer. We have accomplished the task at hand. It wasn't too difficult. It was less than 100 lines of code. We're missing a couple of features. We need a placeholder, and we need that onCommit callback. Both of these are pretty trivial. I'll probably record a follow-up to this. I will also include that code in wherever some link below, above, on top of this video. I don't know where I'm going to post this, but thanks for watching, and feel free to ask me any questions via whichever communication links I scatter near the repo link. I hope that was interesting. Thanks for watching.